Hello, I'm just about to start this problem. Let's see, what time is it now? It's 10:12 p.m. Okay, what am I doing? What is this problem? I'm given an inclusive range in a sorted unique integer array nums. So, okay, sorted, unique, good to know. So this is sorted and unique. I'm just going to grab an example to look at as I read along. This is sorted, all the numbers are unique, the range is inclusive, that means upper is part of the range. A number is considered missing if x is in the range, if it's in this range, but it's not in here. Return the smallest sorted list of ranges to cover every missing number exactly. There's no element of nums is in any of these ranges. No element of nums is in any of the ranges, and each missing number is in one of the ranges. So each range should be like this. Okay, there are two situations. So if a range only has one number, okay, so interesting, the ranges are strings. Okay. And if a range is only one number, then just display the number. This looks pretty straightforward, I suppose. Let me just try solving it using 2 pointers. That's a technique that comes to mind. This sorted and no dupes is what I remember. These are the 2 pointers, so I'm going to send so it's going to be, these are not going to be in the range. So let me see, the range is going to be like this, or I'm going to put it in a result. There's nothing in between 0 and 1, so I'm just going to move these 2 pointers forward. There's the 2 numbers are, let me just have 2 variables, min or lower and upper. Initially they're none, but it's going to be 1 plus 1. I'm going to add 1 to this number and subtract this number. 3 minus 1, this is 2, this is also 2. They're the same, so I add 2 here, like this, I suppose. Then I move this forward, and I actually don't need this pointer. I can just look at I plus 1. That. So then this is going to be, I'm going to add 1 to this to get 4. We subtract 1 from this to get 49. That. And they're not the same, so I just add 4 to 49 here. Then I move this forward. This goes forward implicitly. This is going to be 51. This is going to be 74. Right? And so I'm just going to add this to the range. This goes up, this goes beyond. So this is going to be 76. This is going to be what's an upper, and they're not the same, so I just add them. This. Let me consider what happens when the first number, let's say it were just like this. Let me just do this again. This is one example, but I want to create a case in which it doesn't start with 0. So yeah, so if I were to start here, yeah, so I guess I can special case this. If I see it's not equal to lower, then I can just subtract 1 from here. For example, just lower is just lower include just this right here. And I could do it a different way too. So maybe this is the upper part of the range. So if there's no basically if there is no previous element, then the lower is going to be 0. The upper is just going to be 3 minus 1, which is 2. So here 0, 2 would be added to the array. This goes up. I would look here. So I would add 4 and 49 to the array like this. Then I goes up. This goes up here. This becomes 51. This is 74. And I'll add this entry to the result. This goes out of bounds. And so that means I look 1 before it. And this becomes 99. It's going to be 76. We're good. So this is deceptively easy. So time is linear. Space is also, it's constant because we're only using these variables in this pointer. Well, I don't see any issues, so I'm just going to start coding that. I'll handle what happens when nuns is empty later. Nuns is empty. Let me see the ranges for this. I guess it could be empty actually. Length could be empty, yes. The two ranges could in fact be equal. Okay. Sounds good. Let me just set up a test case for that. So let's say lower or 3, upper or 3. And it were just empty and also 3 like this. I is already out of bounds, so basically lower is going to be 3, upper is going to be 3. If you remember, the logic was if there's nothing before I, we set lower to 3. If there's nothing, if I is out of bounds, so we set upper to the upper bound. So, and then since these are the same, we'll just add 3 to the result. Oh, here we might get a dupe. That's not good. This might be the interesting case. So here lower, so I is here. Interesting. This is where we get a dupe, and that's not going to be good. So I might have to special case. Let's see, lower. Here lower would be set to 3. Upper would be set to 2. Okay, hold on. So if there's nothing before 3, So, okay, this is the tricky case right here. I mean, what did I do here? So if 3, I guess it's a little bit tricky when this matches the lower bound. Interesting. What should I do here? So I've got a 3 here. I starts off here. There's nothing before the 3. So we want to set this range 3, 2, just 1 before this number. We see that oh, this can't happen. Oh, wait. Okay, so this is not a valid range. Okay, so the what we should return here, I got confused for a moment, is nothing, because we want to return ranges for things that don't appear in the array. So we got a bounds. We set the upper bound to 3. We set the lower bound to 4. It's not a proper range, so we don't add anything. We get a proper target, which is this right here. Wow. 12 minutes. Articulate it and approach. Test it comprehensively. Well, it should be not difficult to code, so let me do that. I'll take a concrete example to code with. Let's do this one. I was going to start off at 0. That. So go ahead and use this diagram to help me code. So 0. Colon. It's a for loop. I probably could just use a for comprehension, but decided to go with this instead. So I is pointing to a 3. Actually, I should use different characters. I'll use L and R here. L and U. And here lower is going to be 3, and upper is going to be 99. That. So the first range we add, it's going to be lower. So I guess I could just start this off here like this. This is initialized to lower already. So if so here there's nothing before I, so we don't do anything. We don't set lower. We do set upper. So upper, if I greater than 0, and lower is equal to nuns I minus 1 plus 1. It's actually going to be L. Test that in a bit. Else L is a bit lower. I'll do it this way. I like it this way better. Okay, so that's lower. How about upper? So upper is equal to nums I minus 1. So that's 2. So initially this is going to be 2, and this is going to be 3. So there's several cases. If L is less than U, and we add if we have a proper range, then we add I'll work on this a bit later, but if we don't have a proper range, we just do nothing, we just pass. So I goes up this, so now I is in fact larger than 0, so we set L to 3 plus 1, which is 4, and then we set upper to the current number minus 1, which is 49, that, and we do see this is true. Go ahead and add these numbers. This is to L and U. That. If they're the same, we just add one number. This. Nums I. Actually, L. That. So we add 449 to the result. And here we add, well, this will be set to 51. This will be 24. That. This will be true. We'll add this. This will go out of bounds. So once out of bounds, we have another one, which is upper is equal to, or U is equal to upper, L is equal to nums I minus 1. I gotta be careful with this one. If length of nums is greater than 0, with this, assuming that we follow the same logic right here. Or I could actually just change this like this. So let's do it this way. If I is equal to length nums, that, this, then I will set upper to, wow, it's kind of messy. I guess I'll just leave it the way it was before. Like that. And that should work. What happens if nums is empty? Then nothing is yeah, what does happen if nums is empty? Then the desired solution is the whole range. And yeah, I gotta change this to if this isn't quite right. Change this here. If length nums 0, else lower. And that should work. Oh shit. L is none. Should not be none. L should not be none. Oh, U is. Oh, yeah. It's like this. Duh. Okay, so this is wrong. Oh. Ah, yes. Got this right here. Duh. Convert to a string. Okay, that matches. Oh, why was one not added here? Oh, fuck. No, I messed up. It's this one. +1. Totally forgot. So that works. Let's just try these right here. One. This is the default one. Oh, that's the one I tried. Let's try this one. Let's try this one. Oh, I forgot this as well. It's a good thing I'm doing this. And test this out carefully. Let's try a negative number. That should be fine. It should be empty. Seem to provide fairly comprehensive test cases for this one. And next two. I think that should be good. 1034 finished. Let me think of other cases. That was pretty easy. So start to finish, that was 22 minutes. That's kind of slow for such an easy problem. But there you have it.